Hello, so my name is Brian Otaka and I'll be taking you through the project which was to design an intelligent mobile phone detector. So how and about this, I designed a mobile phone detector circuit that will detect phone signals in the surrounding, and a mobile phone jammer circuit that will jam the detected phone signals, and after which both of these circuits are combined and integrated such that the mobile jammer circuit will rely on the detection of a signal for it to turn on instead of remaining on throughout. So the reason for this project is because there has been a great need to control the use of mobile phones in places of worship to prevent distractions in schools, to reduce the number of cheating, and as mobile phones become more and more widespread, so has the need to control their use. So first we have the mobile detector circuit, which I will simulate. So at the function generator we input a signal of 800 megahertz, which is sinusoidal. This is the RF coil is simulating how the signal will behave like a normal phone signal, and is fed to this capacitor C3, which is a disc shaped capacitor that is collecting the phone signals from the air, and this in turn is fed into the operational amplifier that converts it into electrical signal, through which we have this transistor Q2 acting as a switch, and when a signal is detected it turns the LED on. So if you look at the output, we have two waves. We have the sinusoidal wave, which is the wave at the signal generator, and we have the wave at the LED, which shows that currently the voltage is 1.73, after which at 1.75 volts the LED turns on, showing that signal has been detected. So although the time for this it's taking some time during simulation, the actual time spent is in microseconds, which will be hardly noticeable in a real world environment. As you can see, the LED turns on, showing that a signal has been detected. And here we have the mobile jammer circuit, which I will simulate. So capacitor C1 and C2 are amplifying the signal that is produced by the combination of the inductor L1 and capacitor C3. So this combination produces 800 megahertz according to a given formula. So signal is produced here, which is amplified by this resistor, after which capacitor C4 and C5 generate the noise, and capacitor C6 removes of the signal so that we can only observe the AC part. So when we run it, we can see that a signal is produced with varying amplitude, and on further investigation we can see that the signal is a triangular wave with varying amplitude. So this is our nice signal. So now we have the combined circuit of the mobile detector and mobile jammer. The two circuits are combined with a voltage controlled switch that is applied across the LED. So if the voltage across the LED is more than 1.7 volts, the switch closes, which will then now provide power to the rest of the circuit, which is the jamming signal. So the caveat to this, so as you can see now, a signal has been detected from the oscilloscope here, and the voltage control switch is now closed, meaning that a signal is being produced on this side. And if you look at this signal, this is the jamming signal, before which you can see a signal of varying amplitude with a lot of noise on it. So this is the noisy signal that is used to jam the phone signal. And the caveat to this is that the jammer circuit does not turn on until a signal has been detected, which is dependent on the voltage controlled switch. So to conclude, that was the mobile detector and jammer simulation that showed that they were working, including the integrated circuit. Thank you for watching my presentation.